Now here the question is, let the sides of a triangle be decided by throwing a die thrice. If the probability that triangle is isosceles or equilateral is P by Q, where P and Q are relatively prime positive integers, then Q minus P is. Now, when we throw a dice thrice, then we'll get some numbers. In some cases, a triangle may be possible, and in other cases, a triangle is not possible. Now, what we'll do is we'll start counting number of equilateral triangles. Now, if we look at number of equilateral triangles, there'll be 6 cases when we have 1, 1, 1, 2, 2, 2, up to 6, 6, and 6. So there'll be overall 6 equilateral triangles. Now, next we'll consider triangles which are isosceles but not equilateral triangles. Now, with 1 we can only have 1, 1, 1. 1, 1, 2 will be a straight line. So the first isosceles triangle we'll get is with 2. So it'll be this 2, 2, 1. Then 2, 2, 2 will be an equilateral triangle. Then we'll have 2, 2, 3. Now 2, 2, 4 will be a straight line. And the same way we'll have 3, 3, 1, 3, 3, 2. Now 3, 3, 3 is equilateral. We'll have 3, 3, 4 and 3, 3, 5. 3, 3, 6 is again a straight line. Then we'll have 4, 4, 1, 4, 4, 2, 4, 4, 3. We'll discard 4, 4, 4. Then 4, 4, 5 and 4, 4 and 6. So we have 2 cases here, 4 cases here and 5 cases here. For 5 also we'll have 5 cases except for 5, 5 and 5. And for 6 also we'll have 5 cases here. So total number of isosceles triangles which are possible is 15 plus 6, and there'll be 21. Now if we look at scalene triangles, now for scalene triangle, if we consider smallest side as 1, then we'll get either an equilateral triangle or an isosceles triangle. There is no other way possible. Now we'll consider 2. Now if it is 2, then one of the triangle possible is 2, 3, 4. Now 2, 3, 5 is a straight line. And then we'll have 2, 4, 5. And also 2, 5, 6. And the same way smallest side is 3. Then we'll have 3, 4, 5. We'll also have 3, 4, 6. And then we'll have 3, 5, 6. And also it'll be this 4, 5, 6 considering smallest side is 4. So here we have 7 cases. So there'll be these 7 scalene triangles. Now total number of triangles that are possible will be this 6 plus 21 plus 7, which is 28 plus 6, 34. And out of these 34 triangles, the triangles which are either isosceles or equilateral, there are 6 plus 21, which is 27. So this required probability that triangle is either isosceles or equilateral will be this 27 by 34, which is given as P by Q. Now we need to find the value of Q minus P. Now 34 minus 7, it is 7. So answer to this question is 7.